Today we're going to talk about line of best fit, exponential lines of best fit, and correlation coefficient examples. So you'll notice on my paper I've got numbers 1 and 6 highlighted and number 3 is marked out. The highlighted ones you are going to do on your own, and the one that's marked out and the ones that are marked out on the next few pages, you will hold off on those. We're going to do those at a later time. So for now, we are going to start with number 2. So this table shows the average verbal and math score on a test for students in 7 states. We are asked, using the line of best fit for the data, what is the approximate predicted average math score for a state that had an average verbal score of 500? So if you look at first, we can see that we want to use the line of best fit. So when you see those words, line of best fit, that means we're going to be using a linear model in the form of y equals mx plus b. We just have to make sure that we're using the correct steps in Desmos to get what we need. So first, in Desmos, in order to find a line of best fit, you're going to add the table that you have your data points in. So if you click that little plus button and table, that pulls up a t-table for you, and you can type in all of those values. I'm going to do that now. It's going to take a minute or two. So I want you to type these in with me so that you can get some practice in doing this on your own. Alright, so I've got my points in, and your screen might look zoomed out like this, so you may need to zoom out a little. I'm going to zoom back in. So now you can see on my Desmos screen, you can see these numbers here, 650, 600, 550, and down to 400. And then down at the bottom, you see 400 and 450. That is my axis kind of moving with the window as I zoom in or out so that we don't have to scroll back and forth so much to see where we're at on the X and Y axis. So this tells me I've got these points, they're all in the 400s kind of range. And I can see from these points that they do form the pattern of a line. They're not an exactly straight line, but it does look like the pattern of a line. So what we want is to find, if we were to draw a line through these points, what would be the equation of that line? And that's exactly what Desmos is going to tell us. So I'm going to open up a new box, and in this new box, I'm going to type in this. It's not really a formula, it's a type of equation. And this equation is going to tell Desmos that we want to know the line that would go through those points and fit it the best. So we type in exactly what you see. Y1, click ABC to get the squiggle, MX1 plus B. Now, after I type that in, notice my line comes up, this red line here goes through those points. It doesn't go through all of them because they don't form a straight line exactly, but it is a pretty good fit. Now, underneath Y1 squiggle MX1 plus B, I see some statistics, I see some residuals, and I see some parameters. So those three categories, they're going to tell us some different information. So first, if I just want to create the equation for the line of best fit, we're going to look at the M and the B so that we can create an equation in the form y equals mx plus b. So we're going to take the M, we're going to round it to 2 decimal places and say that's 1.18. So that gives us y equals 1.18x. And then my B value is negative 32.42. So this is our equation for the line of best fit. We put this table in Desmos. We told Desmos to find us a line that fits these data points. And then Desmos told us for that line that fits these points, this is the slope and the y-intercept of that line. So slope and y-intercept of that line. Now, our question was not just to find the equation. The question was to find the math score if the verbal score is 500. So the verbal score is X, right? So if the verbal score, X, is 500, that means I'm going to take 500 and plug it in for X. Okay, so we just take 500, plug it in for X, and we want to know what is the average math score, right? So what is the math score? So what's the Y value? What is the Y value if X is 500? So over in Desmos, all I want to know is what is 1.18 times 500 minus 32.42. So that's what we're going to type in. 1.18 times 500 minus 32.42, and that gives us 557.58. So if we're going to round this, you notice that word approximate in the question. If we were to round this, that is closest to 560, right? So just to make a note of it, we actually got y equals 557.58, which is very close to 560. Okay, so I want you now to look at number 1, and I want you to find the line of best fit, right? So this question says, which linear equation best fits Lisa's data? So in this question for number 1, I want you to open up Desmos, close out all of the tabs that you had, click the little house button over on the right side of your graph screen. That will take you back to a standard zoom, and it clears out all of the information that you had already typed into Desmos so that you're not getting any information mixed up. Now I want you to try number 1 by first adding a table, and then you're going to type in all those X and Y values for fat in grams and carbohydrates in grams, your X and Y, and then type in your Y1 squiggle MX1 plus B into Desmos and find the equation that fits this data. Moving on to number 4, the table below shows the amounts Jeremiah plans to receive at the end of each year from one of his investments. So he has an investment, he has put some money in, and he is expecting that money to grow. So we have the number of years and his amount of money in the bank on this investment. So what is the correlation coefficient, and which statement best describes this relationship? So correlation coefficient. We haven't talked too much about that. We're going to explore that more today in these examples, so you have some something to look at and see exactly what we're talking about with this. So to find a correlation coefficient, that shows up in Desmos when you find a line of best fit. So first, let's put this table into Desmos, plus table, and just type in your values. Okay, so I've got 0 through 6. All right, now I can't see any of these points on my graph, but I can zoom out Whoa, there they are. Okay, and they look pretty steep. This is a pretty steep line, and that's okay. But those where my points are. And then we're going to tell Desmos to give us a line that goes through these points. Now, we are trying to find the correlation coefficient, but we can't find the correlation coefficient without telling Desmos to give us the line of best fit that all comes together all at one time. So y1 squiggle mx1 plus b. So here, in all of this information that's given us, the last two things, the m and the b, that's all we used for the last two problems that we've done. What we're going to look at is the r value. So if you'll look, you can see where it says, I'm going to do this in a different color. Let's see. So if you look, you can see where it says r equals, it says 0.9895. Okay, now we're not looking at r squared. We are not going to be dealing with that at all. We are just looking at r. And r is 0.9895, which from our answer choices down here, if we round that to 2 decimal places, that's closest to 0.99. That would round up. Now, we've talked a little bit about weak and strong versus positive and negative. So this number, it is a positive number. It doesn't have a negative sign in front. If it had a negative sign in front, that's the only thing that negative tells us, that it had a negative slope. This one has a positive slope. So it's positive because it doesn't have a negative sign in front. And since we got a line that goes through these points and fits it well, our R value, 0.99, that's really close to 1. So since it's close to 1, we say that is strong. I'm going to say strong because it is close to 1. Okay, so if you get a decimal number that is like 0.1, 0.2, things that are closer to 0, then that's going to be weak. But strong is anything that's close to 1. I like to think of your R value being like change for a dollar. You're either close to a dollar or close to a negative dollar, or you're close to nothing. So typically you'll see values that are 0.7, 0.8, 0.9, or you'll see values that are 0.1, 0.2, 0.3. You won't see a whole lot in the 4, 5, 6 range. So typically we just say the closer it is to 1, the stronger it is, and the closer it is to 0, the weaker it is. Okay, now in number 5, let's look at the scatter plot and see which of these correlation coefficients would fit the scatter plot. So we talked about in our tree map that if you have a scatter plot that does form some sort of pattern, so this forms kind of a linear pattern, it would look something like this. Maybe not quite that high up, maybe a little more like this. Okay, so since that scatter plot forms a linear pattern, we would say that it is strong because it has that linear pattern, and this would be a positive slope. So we need a strong positive correlation coefficient. So the negatives, we can cross those out because this is not a negative slope, it's a positive slope. And then we're looking at 0.7 or 0.2. Which one is closer to 1? Yeah, it's this one. 0.78, 78 cents is closer to 1 than 23 cents. So this is our strong positive correlation coefficient. All right, I want you to try number 6. The correlation coefficient of a set of data is 0.95. Which of these statements can be made about the linear association of the data? All right, let's look at number 9. The table below shows the population of a state in different years. What is the meaning of the y-intercept of the line of best fit for the data? Okay, so we don't see a whole lot of numbers in our answer choices. It's just asking us to say what would the y-intercept mean. So we don't actually have to find the line of best fit for this data. It's asking us for the meaning of the y-intercept. So if we were to represent this with an equation, we could put the table in Desmos, we could find the line of best fit, write the equation, and look at what the y-intercept is. However, that number doesn't tell us much unless we understand what it represents. So generally speaking, we have talked about mx plus b, where m is the slope and b is the y-intercept. Now, another word for y-intercept is the initial value. We have said this over and over. So the initial value would be when this is 0, what is this y value, right? We talked about how to find y-intercepts in a table. It's always where the x is 0. So let's think about if we had 0 here. Well, these x values here are the years since 2005. So in the years since 2005, if that was 0, then 0 years have passed, so you would be in the year 2005. So the initial value would be the population in 2005, and then 1 year later, the population is given. 2 years later, the population is given. But at year 0, that's your initial value, and at year 0, that would be 2005. So this really was nothing more than just understanding what is an initial value, especially when you're interpreting years since a certain date. Number 10. In the following table, Shayna recorded the amount of money in thousands of dollars, Y, that her investment was worth after X years. So Y is thousands of dollars, X is a number of years. If this exponential trend continues, approximately how much will her investment be worth in year 7? Some key words. I see exponential trend, and I see how much will her investment be worth in year 7. So before we go into how to do this in Desmos, let's think about what will this equation look like. We know that exponential functions look like y equals a times b to the power x. So in Desmos, when we want to find that when we want to find that exponential model, we want to use that form of an equation. y1 squiggle a times b to the power x1. Alright, so in Desmos, once again, I'm going to click this little house button, get us back to a standard window, and add a table. So we're going to put in our values 0 through 5. Right. Now, just looking at this table and looking at those points plotted on the graph, I can see that it's starting to look like an exponential curve. It's starting to kind of look like this a little bit, right? Now, we want to know if this trend continues, how much would her investment be worth in year 7? So in year 6, we don't know. In year 7, we don't know. But what we can do is we can find out how is x related to y, how is y related to x, and we can write an equation using Desmos. So let's type in to find our initial value and the base, y1 squiggle a b to the power x1. So I'm going to walk through that again. Okay, we'll walk through that one more time so you can see it. Y1, squiggle, A, and you can put parentheses for B if you want to, B, and then the power button, it's this A to the power B. Our exponent is x1. Now we have to click this button that says log mode. Just want to make a note of that for you. Because if you don't click log mode, you see how we don't have those R values the way we need? We need an actual R value. Now let's look at this R value. It's exactly 1. So if an R value is exactly 1, that means it is a perfect fit. So this equation that we're going to write is a perfect fit for this data. So y equals, our A that it gives us is 3. If we round to 2 decimal places, that would be 3.00. So I'm just going to leave it as 3. And the base is 1.24, but we're going to round that 4 up to a 5 because of the 9 that's behind it. So 1.25 is the base to the power x. All right? Now, this is our equation, but we can't stop there. We want to know how much this investment is worth in year 7. So what is y? What is the y value when the x value is 7? So we are going to type in Desmos, y equals 3 parentheses 1.25 to the power 7. So now we're going back to what we did in our exponential functions unit. Y, whoops, we don't have to type y equals. You can, but you don't have to. I'm going to do it both ways. Y equals, here we go. Okay, so you can do it that way and it tells you y equals something, or you can just type in 3 parentheses 1.25 to the power 7. Same thing. All right, so that's 14.30511. Now, we want to know, how much is this investment worth? Is it worth $14? How can we tell? So what's the difference in answer choice? Let's see, we know it's not B, we know it's not D. What's the difference between A and C? Well, let's go back and read the question again. The following table, Shayna recorded the amount of money in thousands of dollars. Y. So Y is in thousands. So where we have Y equals 14.305 thousand. Read that back in your head. 14.305 thousand. $14,305. That one can be really tricky, and that's one that you will have done all this work, and to get one like that wrong on your test just because you didn't read quite carefully enough as to what the Y represented, let's try to avoid any of those mistakes. All right, almost about halfway done, probably a little more than halfway done. All right, I'm going to close everything out. Got back to a standard Zoom window. All right, now, the set of data below, determine the equation that best fits the relationship and explain the meaning of its key features. So we aren't necessarily told if this one should be exponential or if it should be linear. So let's find out how we can tell. All right, so I'm going to put this table in. Remember, your x values are on the top. I want you to be putting this table in with me. Okay, so looking at this data, there's only 4 or 5 points. Oh, there we go. So just looking at this data, because it's so spread out, I want to go ahead and think that it's exponential, but I want to make sure that I'm correct in saying that. So what we can do is say, I can see how these are so spread out, right? The first 2 points from 0.75 to 2.3, that's not a very big jump. 2.3 to 7.8 is not a huge jump. But then 7 to 21 and 21 to 60, it looks like if I'm going from less than 1 up to a little more than 2, and then to over 7, and then over 21, and then more than 60, it looks like I'm getting about 3 times as big each time. So I'm going to think that this is exponential. It looks like we're multiplying by some number. It's just not very clear. So let's see if it is exponential by looking at the regression model. Y1 squiggle, A parentheses, B to the power x1, log mode. All right, so let's look at this R value. So this R value, I'm going to make a note in here so you can kind of follow along with me. So when I had y1 squiggle A, that was B to the power x1, that gave us an R value of 0.9994. I'm going to write that down. So what an R value does is it tells you how strong or how good of a fit this exponential equation is. So this graph that it gave us, it's telling us that there is 0.9994 strength there, where 1 is the strongest that it can be. And this one's at 0.9994. Now let's look at the linear model and see how strong that one is. Y1 squiggle mx1 plus b. So if I try to fit a straight line to this, let me make a note of this. For y1 squiggle mx1 plus b, the R value is 0.8827. So what happens is we've put in our exponential fit, we've put in our linear fit, and Desmos is telling us with this R value which one is stronger. So since this R value is stronger, we're going to say this is exponential. So we don't need to look at this linear model anymore. We're just going to focus on the exponential. So we also want to know what is the equation, right? So we've got A is 2.34, so that would be Y equals 2.34 is your A value. The base is 3.00 or 3.01 to the power X. So that fits option B that says this equation, the initial value is about 2.34 and is approximately tripling for each increase in X. So that approximately tripling, that means your base, the number you're multiplying by, is about 3, right? So if I said we're multiplying by about 3 each time, that means we're basically tripling each time. Right, so that is option B. Right, with number 13, I actually want to just let you try this one on your own. So I want you to try to see what you can do on this one, but think about what it means to have a strong positive or a strong negative relationship. So typically, just to give you a few notes down here, if you have a strong positive, then that means as your x's increase, your y values also increase. If you have a strong negative, which we took notes on, if you have a strong negative, that means as your x's increase, as your x's go to the right, your line's going down, your y values are decreasing. So again, strong positive or strong negative. And then if you have a weak correlation, a weak positive is possible, but you won't come across that very often. It would just be if your value was like 0.1, 0.2, 0.3, and the same rules would apply for positive versus negative. For number 14, let's look at this one. A car dealer recorded the selling prices of his used cars in 2005. The table shows the average selling prices based on the age of the cars. Which best describes the correlation between the age of the car and the selling price of the car? Okay, well, let's look at this. I'm going to zoom in a little so we can see it well. All right, so I'm looking at my X values, I'm looking at my Y values, and I just want to know, is it variable correlation, negative correlation, no correlation, or positive correlation? So it's not asking me to find the R value, it's just asking me to describe, is there a positive, negative, or no correlation? We haven't even talked about variable correlation. That's not a topic that we've covered. So we're not even going to consider that one. It's either positive, negative, or no correlation at all. So let's look at this. As my X values increase, right, so +1, +1, these are all getting larger. My Y values, what's happening to them? Generally speaking, we're going down 2, we're going down 3, we're going down 2 again, going down 5, going down 3, but overall, they are going down. Those values are going down. So as one value, so as your X values increase, the Y values decrease. So if they're going in opposite directions, think about what that would look like on a graph. As your X values get larger, your Y values get smaller. So that would be a negative correlation. If they're both increasing, that would be positive. If they're both decreasing, that would be positive. But if they're going in opposite directions, that's a negative correlation. Number 15, I want you to try on your own. So first, I want you to make sure that you clear out everything you have in Desmos. Click your standard home zoom again. Make sure that you've got that 10 by 20 window approximately. And number 15, I want you to try on your own. So again, you're going to put your table in, plus table. And it's going to ask you if the data below models an exponential function. So again, you're going to have to type in y1 squiggle a b to the power x1. And then determine which of those is the most appropriate.